Mathematics Clinic. On our today's class, we would want to see how we can be able to use one of the mathematics software called the Scientific Workplace to solve a differential equation. Although Scientific Workplace can do a whole lot of things like data analysis, data presentation, interpretation, which we at the Chesed Mathematics Clinic, we can also use it to work and help you out with your data analysis and presentation if you are into any research or a project work or any other research work that you're into. But today, our class on this tutorial will be dealing on how we can be able to use the Scientific Workplace to solve the first and the second order differential equation, also showing the solution on the graph. So the first thing we have to do here is, of course, we have to save this file. And how do we save these documents or file? We go to File and we save as. On Save As, we save it on desktop, and let's call this tutorial 1. Right. So we are saving this. Okay, it already exists. Let's replace. Let's say yes. So we are saving this as tutorial 1. The next thing we need to do is to work with what we can see on the interface here. We want to use a fraction. So we pick up a fraction, and then let us call the first derivative dy over dx. But before we do this, we can also set it on maths. As we can see here, it has been set on maths. I can change it back to text. I can change it to maths. Okay, so it's on maths. We can use the shortcut button, which is Control M or Control M as well, to change it back to mathematics. And so this is the fraction for it. So we have dy over dx. And we want to differentiate this with respect to x. And what is the function? It is 3x to the power of 3. We pick out this as a power of 3. Then minus 5x. If we want to pick another power, we don't necessarily need to use this. We can go use the shortcut, which is Control H high. So which is 2. Then plus 2x minus 7. So we want to differentiate this with respect to x using the Scientific Workplace. The next, we go to Compute, we click on Calculus, and we pick Implicit Differentiation. It's now asking us the differentiation variable, so we are differentiating with respect to this x. So we put in x here, and we OK it. So this is the solution of the first order differential equation of this function. This is the solution. And how do we get the graph for this solution? We go to Compute again. We come to plot 3 or 2D. That's 2-dimensional or 3-dimensional of this solution. And we find the 2-dimensional, which is the gradient or the slope. We pick it up and it is loading. So this is the graph for the first order differential equation. Next, we want to find the second order differential equation of this same solution. So how do we get the second order? So for us to get the second order of this solution, we pick this. Let me copy this work. Control C, enter. I will paste it, but before I paste it, I will still pick up my fraction. I want to differentiate the square y over the x square, which is equal to, I'll paste that work that I've copied. So I want to differentiate this first derivative with respect to x again. We use the same method. We go to Compute, Calculus, Implicit Differentiation, and we put in the variable which we want to differentiate, which is with respect to x. We OK it. So this is the second solution or the second derivative of the differential equation. Next, we plot the graph. We go to Compute, 2-dimensional, gradients, and this is the graph or the solution to the graph for the second order differential equation. So you are always welcome to the Chesed Maths Clinic with Scientific Workplace, which is one of our mathematical tools which we use. You can always like, comment, and share. If you have any question, please don't forget to drop it on the comment section. If you have any work you want to work with, you can always call us on. So we use our mathematical softwares to help you out with the analysis and the presentation. Do have a wonderful time. Bye bye.